Last spring, I stood in my backyard staring at 7 tomato plants. That had cost me $44 in starts, another $33 in bagged soil, and 2 full months of meticulous watering. Every single one of them was wilting. The leaves curled inward like clenched fists. The fruit split before it could even ripen, and when I pulled one plant out of the ground, the roots barely reached 4 inches deep, because the soil underneath was essentially concrete with a marketing label on it. In my field records, I have documented this exact phenomenon hundreds of times. The systemic collapse of expensive store-bought inputs when they meet depleted native ground. That same week, my records show that a dozen eggs at the store hit $5.50. Lettuce was $3.85 a head. And the news was running another segment about a freeze in Florida wiping out citrus, a drought in California cutting almond yields, and a shipping delay doubling the price of canned fish. Every direction you look, the cost of feeding yourself keeps climbing. And the one thing you are told to do about it, grow your own food, turns out to be its own expensive, time-consuming trap. You buy the raised beds, you buy the amendments, you fight the pests, you water on schedule. And at the end of the season, you have spent more than you would have at the grocery store, only to harvest a handful of undersized peppers and some basil that bolted in July. Through my analysis of energy capture, I've realized that this isn't a failure of your green thumb. It is a failure of the extractive model we've been sold. Here is what nobody tells you. The problem is not your thumb. The problem is not your soil, not your climate zone, and not the number of hours you have available. The problem is that the entire way you were taught to think about producing food is modeled after an industrial system that needs you to keep buying inputs every single season. Seeds, fertilizer, pesticides, irrigation kits, and replacement soil. It is a treadmill. And it was designed that way to ensure dependency. But roughly 3,500 years ago, along the Yellow River, farmers noticed something that quietly disproved everything we now accept as normal. After seasonal floods pulled back, shallow depressions stayed full of water. Fish got trapped in them. And instead of dying, those fish kept growing. They reproduced. Villagers walked over, scooped out dinner, and walked home. No feed bill, no equipment, no supply chain. Just a low spot in the earth, some water and time. In my study of ancient aquaculture, I've found that those farmers were the first to recognize a closed-loop system where nature does the heavy lifting. Those farmers started paying attention. They packed clay along the edges of those depressions to hold water longer. They dug them a little deeper, so fish could survive through dry months. And what they ended up with was not agriculture in any way we would recognize today. It was cooperation with a process that nature was already running on its own. Humans did not engineer the system, they just stopped interrupting it. By around 1600 BCE during the Shang dynasty, these ponds had become a normal part of household life. Archaeologists found inscriptions on oracle bones. One phrase kept showing up: fishing in the garden. Scholars initially dismissed it as poetry. Turns out it was literal. Families were managing small fish ponds right next to their vegetable plots, pulling protein out of their own backyard water the way you or I might pick a pepper off a bush. I've cross-referenced these archaeological finds with modern small-scale yields, and the calorie density is staggering. Then, more than 2,000 years later, a man named Fanley wrote it all down. His book, The Classic of Fish Culture, laid out something that still sounds radical today. A correctly built pond, even a small one, can generate more protein per square meter than livestock raised on the same footprint of land. 4 inputs: water, sunlight, living organisms, and patience. Once the biology inside that pond locks in, it can keep producing for decades, without you dumping feed or chemicals into it. Entire villages in ancient Asia ran these ponds for hundreds of years, generation after generation, feeding families from the same water their great-grandparents had stocked. And then, almost overnight, the whole thing nearly disappeared. During the Tang dynasty, the emperor's surname was Lif, which, in the spoken language of the time, sounded almost identical to the word for carp. Killing or farming something that shared the imperial name was considered an insult to the throne. So the court banned carp farming outright. For millions of ordinary families who had depended on that one fish for centuries, of cheap, reliable protein, the ground just dropped out from under them. This is the cycle almost every backyard grower gets trapped in without realizing it. You till because someone told you loose soil is better. You fertilize because the plants look pale. You spray herbicide because the weeds come back twice as aggressive in dead soil. You buy bags of so-called nutrient-rich potting mix because your native ground seems hopeless. Every step feels logical, every step costs money, and every single one of them moves you further from a system that could have sustained itself. In my logs, I categorize this as input-addicted gardening, where the soil is treated as a dead medium rather than a living laboratory. But we buried that knowledge. We replaced self-sustaining ponds with decorative koi features and garden fountains. We turned a food-producing system into a landscaping accessory. And in its place, we built an agriculture that demands you come back to the store every single season, wallet open, hoping this year the tomatoes actually survive. I used to do all of it, the tilling, the fertilizer, the expensive soil amendments. My beds looked clean and professional and produced almost nothing. That is when I started asking a different question. What if the problem was never my skill? What if the entire method I'd been taught was designed to keep me dependent rather than fed? Because when researchers at Auburn University in the 1960s decided to test whether a small backyard pond could reliably produce food, they didn't use any of the industrial machinery or chemical inputs we've been told are necessary. They dug modest ponds, barely the size of a swimming pool, stocked them with common local fish, and watched what happened. What happened is that nature did exactly what it had always done when we stopped poisoning the process. I've reviewed the Auburn datasets, and they prove that the yield per calorie of effort is unparalleled. That raises a question worth sitting with. If a pond the size of your patio can quietly grow protein for years with almost zero input, what exactly have we been paying for all this time? So here is what nobody told you when you bought that first bag of fish feed. There is an entire economy happening beneath the surface of a pond, and it runs on a currency you have never been asked to pay for. Sunlight hits the water, algae bloom, plankton feed on the algae, fish feed on the plankton. That is not a nice little nature fact for a textbook. That is a closed production loop, operating every single day, converting free solar energy into animal protein without a single invoice. And the engine that kicks the whole thing into gear is not some expensive aerator or a filtration unit you ordered online. It is a duck, 3 to 5 ducks to be specific. In my observation of these ecosystems, I've identified the duck as the primary biological pump. When a duck paddles across a pond, its feet churn the soft sediment at the bottom, releasing trapped nutrients back into the water column. Its manure dissolves nitrogen directly into the system. That nitrogen is the spark. It feeds the algae feeds the plankton, and the plankton feeds your fish. The duck is not a pet sitting next to your pond. It is the motor that keeps the entire food chain cycling. And while it does that job, it also hands you somewhere between 880 and 1,850 eggs a year. No one designed this. It just works because the relationships between these organisms evolved together over millennia. Now picture the plant layer, cattails, water lilies, duckweed, all growing along the edges and across the surface. Most people look at pond plants and think decoration, but my analysis of the water chemistry shows that their roots are doing something critical underneath. They are pulling excess nitrate and phosphorus out of the water, the same compounds that would otherwise choke the system with overgrowth and turn your pond into a green, stagnant mess. These plants are a biological filter running 24 hours a day, and they cost you nothing after the first planting. Duckweed alone can double its biomass in 48 hours under good conditions. It is one of the fastest growing plants on the planet, and it is packed with protein. The ducks eat it. The fish nibble at it. It shades the water and stabilizes temperature swings. One organism feeding another, which feeds another, which circles back to the first. When researchers actually measured what a system like this could do, the numbers were hard to argue with. A pond covering roughly 100 square meters, that is smaller than most suburban backyards, produced up to 385 pounds of fish in a single year. Compare that to cattle on a much larger piece of land where you might get 220 pounds of meat. And only after paying for feed, fencing, veterinary bills, and barn maintenance. The pond asked for almost none of that. Most of the food the fish ate was generated inside the water itself. By the same cycle, the ducks and plants kept turning. I call this the efficiency gap, the distance between what nature provides for free and what the industry charges you for. This is the part that should bother you a little. None of this is new science. None of it was discovered last year in a lab. A man named Fan Li wrote about these interlocking pond relationships over 2,400 years ago. Villages across Asia ran systems like this for centuries, feeding families from water features no bigger than a parking space. The knowledge was there, the biology was always there. Somewhere along the way, we just stopped looking at it and started buying what we could have grown for free. So the real question is not whether a small pond can outproduce a pasture. The data already answered that. The real question is what happens when you add fish into this loop. Because not every species plays the same role. And getting that mix wrong is one of the fastest ways to collapse the whole thing. So here is the part that broke my brain when I first understood it. You do not build this system, you trigger it and then you get out of the way. In my experimental trials, the hardest part for the human operator isn't the work, it is the restraint. Think about every food project you have ever attempted. Raised beds, container gardens, maybe even a chicken coop. Every single one demanded something from you every day: watering, weeding, feeding, fixing. You were the engine, and the moment you stopped showing up, everything collapsed. That is not a food system, that is a job you do not get paid for. A pond flips that entire relationship on its head. And the move that starts it all is so stupidly simple, it almost feels like cheating. You dig a hole, maybe 11 feet by 16, 4.5 or 5.5 feet deep. You line it with a basic waterproof sheet, you fill it with water. Then you add a handful of living things and you walk away. Not forever, but close to it. Because what happens next is not something you manage. It is something that manages itself. Drop a few bluegill in that water. They do not need you to schedule their meals. Insects land on the surface, plankton blooms in the sunlight. Tiny organisms colonize the sediment, and the bluegill eat all of it. They spawn multiple times through the warm months, replacing themselves without you lifting a finger. You never restock, you never order fry from a catalog, the population just holds. Now add catfish. They settle to the bottom where the bluegill never bother going. Dead organic matter, larvae buried in the mud, bits of decomposing plant material. Catfish turn all of that into body mass. They are not competing with the bluegill, they are cleaning a floor, the bluegill ignore. Two species, two completely different jobs, zero conflict. You did not design that division of labor, it existed before you were born. Tilapia come in and occupy the third niche. They graze algae and plant matter that would otherwise choke the water. Under warm conditions, a single tilapia reaches about a pound in 5 or 6 months. Converting pond scum directly into protein you can eat. 3 species, 3 layers of the water column, 3 separate food sources. All happening without a feed schedule pinned to your refrigerator. But the real lever, the invisible one, is the bacteria. You never buy them, you never inoculate anything, they just show up. The moment fish produce waste, ammonia appears in the water. Bacteria colonize every submerged surface and start converting that ammonia into nitrite. Then nitrite into nitrate. Nitrate feeds the aquatic plants. The plants filter the water, the clean water supports the fish. That loop closes itself in weeks, and once it closes, you are not maintaining a pond. The pond is maintaining you. In my analysis of capital outlay, the economics look like this. $440 to $660 for the liner. A small batch of starter fish, a few ducklings if you want eggs floating into the equation, and some aquatic plants to kickstart filtration. That is it. That is your entire capital outlay. No monthly feed bill. No electricity for aeration pumps. No replacement costs every season. Sunlight drives the photosynthesis. Microorganisms multiply on their own. And natural food chains stack themselves layer by layer without asking your permission. I used to think a productive system meant more work, more inputs, more control. What I actually needed was less of all three. The pond does not need me to feed it. It needs me to stop interfering with the cycles that were already trying to happen. Every handful of commercial feed I would have thrown in, every chemical algicide I might have poured, every time I would have drained and refilled the water out of anxiety. All of that would have interrupted the very process that makes the whole thing run. Less input, more output. That is not a slogan. That is literally how a living ecosystem operates when you let it. And the strangest part is how long it takes most of us to trust that. We keep waiting for the catch, for the moment the system demands something expensive or exhausting. But the pond just keeps cycling, keeps producing, keeps feeding the next generation of organisms from the waste of the last one. So now the system is alive, but alive and stable are two very different things. And what happens in the first year will test whether you actually trust the process, or whether you panic and start over managing the one thing that was finally working without you. Now picture a moment 4 years from now. You walk out your back door on a Tuesday evening, no list, no car keys, no self-checkout line. You crouch beside a pond that looks like it has always been there. You drop a line in. 10 minutes later, a bluegill is on your cutting board. And the ducks have already laid tomorrow's breakfast in the coop beside the water. That meal cost you nothing. No fuel, no packaging, no transaction. Just your feet on wet grass and a living system that kept working while you slept. While you were away, while you forgot about it for an entire week. In my records, I define this as the ultimate expression of biological sovereignty. Here is what nobody tells you about that 4th year. You stop thinking about the pond as a project. It becomes more like a quiet room in your house you always had access to. The fish are reproducing on their own. The water plants filter themselves. The ducks cycle nutrients back into the edges where your greens grow thickest. You are not farming anymore, you are just living next to something alive that happens to feed you. And then one winter, the news does what the news always does. Supply chain disruption, diesel shortage, egg prices triple overnight. You watch your neighbors line up at 6 in the morning outside a grocery store, with half-empty shelves, buying whatever is left, not what they need. You have seen this before. Maybe it was 2020, maybe it was last year, maybe it is next month. The trigger changes every time. The panic looks exactly the same. But this time, you are not in that line. You are in your backyard, cracking ice off a small opening in the pond. So the fish below can keep breathing in their slow, cold water sleep. The bluegill and catfish are fine down there, semi-dormant, waiting for spring like they have done for thousands of generations without anyone's permission. The tilapia, sure, you already harvested those before the first frost and froze the fillets. That was just a Tuesday afternoon too. This is the part that is hard to explain until you have lived it. The feeling is not pride, it is not even relief, it is something closer to stillness. Everyone around you is reacting, and you are just not. You have food, real food, protein you grew in water and sunlight, eggs from birds that fed themselves off the same pond, greens from soil that the whole system kept fertile without a single bag from the hardware store. That is what a small pond in a backyard actually is. It is not a hobby. It is not a weekend project you show off on social media. It is a quiet, permanent answer to a question most people do not ask until it is too late. Where does my food actually come from when the normal way of getting it breaks? I'm currently tracking the transition points for small-scale survival systems. What is the one thing you keep buying at the store that you suspect you could grow yourself? If you just stopped following the industrial script, drop it in the comments.